Good day and welcome to this video in this series teaching C#.NET for engineers. In this video we are going to continue our introduction to objects, and we are going to build further on the concepts that we demonstrated in the previous video by actually going into some code and putting together how the concepts actually work in code. Just a quick recap of what we discussed in our previous video. We showed that an object or a class in .NET can represent a real entity in the world. It's an abstraction of something real in the world. And in the context of programming for engineers, we showed, for example, that an object can represent a layer in a pavement system, or, for example, a segment on a road network. So here we've got an object that we call that is of the type segment, and we showed in the previous video that these underlined properties are attributes of that object, and they can be used to do all sorts of calculations or draw reports and be used in complex algorithms. We also showed that some of these attributes can be read-only, and some of them can be classes, like the GPS coordinates. So objects can fit like Russian dolls inside each other, and you can reuse them, and that's one of the great advantages of object-oriented program is its reusability. We also discussed the outline of, for example, a road segment class. And in this video, we're actually going to go into Visual Studio, and we're going to code this class. So the concepts that we demonstrated was the structure of this class. We already discussed this also in a previous video. And specifically what I would like to focus on in this video is the concept of encapsulating object attributes using properties. In the previous video, we discussed how you can build a read-only property by removing its setter and only retaining the getter. In other words, it can return a value, but you cannot set that value. And in this video, I'm going to show you why that's important and how that actually takes place or takes shape when you are actually using an object in your code. All right. I think up to now, everything has been conceptual and maybe a little bit abstract. Today, we are going to actually show in code how it happens that you can only access a property, but you cannot modify it. Okay, so before we go over to Visual Studio, I just want to make clear that in our previous videos, we developed two projects. One was a class library and one was a console application. And basically what we're going to do now in this video, we are going to add a class in this library, but then we are going to use that class in the application. So I just want you to be clear that we got two different projects. We're going to build our class in this project and we're going to make use of it. That's the important term. We're going to make use of it in this application. All right, let's head over to Visual Studio and put all of these concepts into practice. So here I am in Visual Studio, and I've got my console application and my library, just like we created in the previous videos. And what I've done is to go into my app, and I've clicked on program.cs. I've got it open here, and I just deleted everything from the previous demo so that I just have this console.readline at the bottom. So now what I want to do is I want to go into the library app, and the first thing I'm going to do in this case, these are the folders. And remember, we said in an earlier video that a folder in Visual Studio maps to a namespace. It doesn't have to be like that, but automatically by default that is the case. And I'm going to create a new namespace here, which I'm going to call road engineering. I'm going to go here, I'm going to right click, I'm going to say add new folder, and I'm going to call that folder road engineering. Now notice the folder is going to map to a namespace, so use the naming convention, camel case, but with namespaces start with an initial capital. And you just enter that. That's a physical folder now on your hard drive under this project. And then I right click and I say add a class. And this class I'm going to call segment. I don't have to call it road segment. I can just call it segment because it's already in the road engineering namespace. And here is my road engineering namespace. As we said in the earlier video, I'm just going to put a semicolon there, and then I'm going to change the modifier for this class to public to make it public. And let's go and put in those attributes that we discussed and demonstrated when we actually discussed the concepts. So I'm going to put my variable block at the top here, private integer, and I'm going to call this underscore road ID. I'm going to say private integer. You can see how GitHub Copilot is helping me there. It's automatically suggested an end reference, which is correct. And then I am going to add a read-only property here, which I'll call private integer length in meters, right? So that's my code block dealing with variables. I showed earlier that you can wrap this in Visual Studio in a region. So by putting in hash, and I put hash region, and I'm going to put here variables, and then I put here an end region. And all that does, it allows me to collapse all of this code so that I can, if my class grows, I can easily collapse code so that I don't have to see all of that at the same time, which is makes it a bit mentally a bit easier to find your way around in a class with a lot of code. Okay, so now I'm going to add a constructor. I'm going to just go and add a region for constructors, because sometimes you may have more than one. And I'm going to remember what we said is that a constructor has no return value, so I don't have to say integer or double or whatever, and it has to take the same name as the class. So I'm going to do it like this, just like GitHub Copilot suggests for me. I've got my constructor here. It's public, just the same access level as the class itself. It's got the same name. Remember, it's case sensitive. And then I'm going to pass in a road ID, a start reference, and an end reference. Now you can see that GitHub Copilot has suggested that I basically add values for all of these variables, but I don't want to pass in the length. I want to calculate it from the start and end location. So I'm going to remove that, and then my length in meters is going to be end reference minus start reference. Okay, now if this was a real production code that I was writing for myself or for my colleagues, I would put in some checks here. For example, as we discussed in the previous video, you want to check that start reference and end reference are positive values. You don't want to put in a negative value. Let's say you've got a rule that all reference locations has to be 0 or bigger than 0. Then you would put that in here and throw an error if somebody enters in here something that shouldn't be there. Now, as I said in the previous video, that somebody is most likely going to be you, yourself. But in a moment, we're going to show you how that can actually happen. All right, so there's my constructors, and I've now got a region for variables. Let's now add a region for properties. Properties. There's my end region. Let's add now a few properties. So I'm going to add a public property for road ID. And you can see that GitHub Copilot has allowed me to actually add a getter and a setter here, but I don't want to allow anyone to modify the value of road ID except through the constructor. Okay, now just be patient. If you don't understand what that means, in a moment I'll demonstrate that. I'm going to remove the setter, and I'm only going to return the value. I'm going to do that for all three of these variables, right? So there I've got my start reference. Notice that I'm using camel case, but with properties I start with public properties I start with a capital, whereas with these private variables I started with an underscore and a lowercase letter. Then I'm going to say end reference, and I'm going to say length in meters, right? And so that's my properties. Then I'm going to add a region for my methods. And I'm just going to have one method, and I'm going to call this get label. I don't want what GitHub Copilot is suggesting. I want to use this terminology. So I'm going to say road ID is road ID from start reference to end reference. And so you can see this is the formatted string syntax that we spoke about earlier. And sorry, I'm just going to remove that override. Don't worry about that. I'll explain that in one of the later videos, maybe in the next series. Just do your code so that it looks exactly like that. So just to get back to this formatting, if you put a $sign in front, then it allows you to put these curly braces and put actual variables between the curly braces, and .NET will build this string for you on the fly, formatted with those values in there, right? So this is everything that we want in this class for now. And I'll just show you how good it is to have these regions defined, because I can now collapse everything in this class just like that. You can see how neat it is. It's very easy. It doesn't matter if this class or object contains 1,000 lines of code. You can very quickly go and say, look, I just want to go and check my constructors, and you can see only the constructors here, right? So that is a very useful way for code editing. Okay, so we've got our object defined. Let's go and do something with it. So now we're going to go into the program.cs, and I want to create now a class of segment. I want to create a segment object. So I'm going to put segment, right? And you can see Visual Studio have added for you there a using statement, because it recognized that this segment is sitting in my library Road Engineering. Right, so now I've got, by putting that using statement at the top, I do not have to type out the full reference path to this class. So if I remove this, then I can still do this, my library Road Engineering segment. I can still write it like that, but you can see this code is very long. And if I have to do this 10 times, then it's a lot of extra code repetition, because I'm going to have to repeat this every time. So the way to do that is much more clear, that makes it much clearer, is to put a using statement at the top, using my library Road Engineering, and you'll see Visual Studio will gray out all of this. And if you hover over it, it'll basically say this is not necessary. So I can now remove this, because I have this using statement at the top. So what is in this? So I'm going to call this segment 1. Remember, as I said earlier, don't get confused because by the name for the class or the object and the name of the variable. This is the class, this is the variable. You can call this anything. Auntie V, right? When I was at school, I had a friend who had a famous auntie that came every holiday and gave them presents, and they all called her Auntie V. So you can call this variable anything. I'm going to just call this segment 1. And remember, if we go and look at, if I hover my mouse over this constructor, remember when I use new in front, it will automatically assume I'm calling the constructor. And you can see there Visual Studio shows me what I'm passing in. I'm passing in road ID 1. The first item is road ID. The second one is the start reference. And the third one is the end reference, right? So segment 1 is going from 100 to 200. Let's make that a bit more realistic. I'm going to say 1001, and it goes from 0 to 423, and I'm just assuming that is meters, right? So you can see this is a very compact way of creating a segment, because in the constructor I am setting its attributes automatically, right? And now let's see how do we access properties or attributes of that segment. So if I want to get the start location, I can do, for example, I've got a start ref, I'm just going to call it abbreviated, is equal to segment start reference, right? So you can see I'm calling this property on this class, and it is going to give me the start reference, which is set in this constructor, right? Now the important thing is that that's a read-only property. If I've accidentally wanted to change the length, for example, let's just get the length first. I'm going to say int length is segment 1 length in meters. And that length is calculated. Remember, if I go back to my segment class and I look in my constructor, you can see the length in meter is calculated. I cannot modify that in this class once I've constructed the class. It's protected in that class, it's made private. So I would not be able to say, for example, segment 1 dot length in meters equals 500. Can you see here? Visual Studio automatically indicates it in red for me, and so it doesn't allow me. This code will not compile. If I try to run this, I will get an error, and it says there were build errors. Would you like to continue and run the last successful build? I recommend you always click no. And now you see here it says property or indexer segment length in meters cannot be assigned to. It is read only. So there's no way that by accident, if your user interface allows somebody to set the length, to modify the length, that your code is going to even allow that, because it will not even compile, right? So it is a very robust way of programming to build your properties and your classes in such a way with private attributes that cannot be modified unless you want them to allow them to be modified, right? So let's go and just modify our class. So with this piece of code, I'm not going to, actually, I don't want to write that. I just wanted to illustrate that your code won't compile if you try and modify a read-only property. So let's go and add a property that can be modified, right? So if I go here to properties, and let's say I add another variable, and I'm going to call this private string. It's a string, and I'm going to call this road name, right? Now notice that my constructor does not take a road name. Okay, so this is going to have an empty or a null value if I don't explicitly assign to it. Let's go and create a property that gets its road name from this variable. So I'm going to say public string road name, and this time I am going to keep the setter here. So just take careful note of the syntax. Again, don't try to memorize the syntax. Just get used to it over time. Ask ChatGPT to help if you get stuck. This is the way you write a property that can be modified and that you can both retrieve and set the value in there, right? So in this case, I am not assigning the road name when I initialize the project. So if I go in here and I say string test, I'm going to call this variable test, and I'm going to get, say, segment road name like that. And then I should get an empty value from there because I never set the road name. Let's run this and have a look at that. If I put a breakpoint there and I run this app, right, here I am. So let's look at what my debugger can show me. If I hover over start reference, it's 0, which is correct. If I hover over length, it should be the difference between the start and the end location, which is going to be 423. So if I hover over length, I get 423. And let's see what happens if I get the value from road name. You can see that value is null. I have not assigned to it, right? And so what I'm going to do now is to actually assign a value to it after I initialize the object. So here I'm going to say, for example, segment 1. It's amazing how good GitHub Copilot is. You can see it just basically gave me an example there. So I've got segment 1, road name is Main Street. And if I now go and put a breakpoint here, and I run up to that breakpoint, if I hover over test, you can see now I am assigning Main Street. However, I can now modify that value again later. So I can say segment 1 road name is, let's call it no longer Main Street, right? Now if I debug up to that point, you'll see that at this point, if I go up to there, the road name is Main Street. Now if I run this line, it's going to reassign the road name. If I step over, road name is now no longer Main Street, right? That may be a bit confusing. Let's call it Victoria Street, right? So you can see now how this is a property that is not private or not read-only. I can actually assign a value to it. And that is something that you have to think about quite carefully when you design your classes or your objects, so that you can be quite sure that you only want to make variables accessible for modification if that is something that you intend the code that is utilizing that object to actually do. Right, so let's just give an example of where we actually call a method on this object. So I'm going to say console write line, and you can see GitHub Copilot has suggested to me that maybe this is what you want to write, but I already have something like that in my code. I can just replace all of this with segment1 get label. Now if I'm calling a method, I have to put round brackets in it. If there's any parameters that need to be passed in, it will go inside the round brackets. But notice that is different from when you call a property. If you call a property, it's just like an attribute. You call it, it gives you a value. You don't pass anything into it. So in this case, you don't have round brackets around it. But if you call a method, let's go and look at segment. You can see here, these are properties, right? And this is a method. Right, so a method, as it looks very similar in the declaration, but here we've got round brackets, and we will typically have much more code in a method than we have in a property or an attribute. Okay, so if I run this, it will show to me the label in the console. Let's run that and have a look. Okay, and there you can see I've got road 1001 from 0 to 423. Okay, and I can now go, let's go and modify that, make it a bit more extensive, and we say semicolon road name equals, and I'm going to just put quotation marks like that, and I put my square brackets, and I'm just going to say road name. Like that. I can either use the variable names, these variable names, or I can directly add the property like that. So I can also say road name like that. Of course, it's case sensitive, so it knows I'm referring to this and not to that. Okay, so you can see if I call road name, the code is just going to go in here, and it will call the getter, and it will return road name. So minuscule faster performance if I just put that road name directly in there. So let's run it now, and we should see the road name is going to be returned with the by the get label function as well. So there we go, road ID 101 from there to there, and it added the road name to it. Okay, so now at this stage you may think, well, that's not too great. I've only got this one segment, and it doesn't do much. But it could very easily be that you could add more data in here. So let's say, for example, I'm going to put in here a variable which I will call private, and this is going to be a list of type double, and I'm going to call this RUT data, right? And this RUT data, I'm also going to pass in here with the constructor. And so you can see I pass in a list of data there. It's private, so nobody can mess with it once I've added it in the constructor. And I'm adding here this incoming variable to my private variable RUT data in this line over here. So let's add a method that can return for us the average RUT depth on the segment. So I'm going to say public double, and I'm going to say get mean RUT depth, and I can now calculate the RUT depth here. We did this in one of the earlier videos, so I'm going to say double sum equals 0, and then I'm going to say for each RUT value in RUT data, increment the sum by the RUT. So I'll just write out this shorthand code a bit more clearly. I want to say sum equal to sum plus RUT, and I'll remove that shorthand, semicolon at the end, and then the average that I return is the sum divided by the number of variables. So as you know, that's what the average is, sum of the values divided by the number of values. Just to make clear, I could do this in a different way. I could, for example, say double get mean RUT depth, and I can just do it like this, because this object, this list of double in the .NET framework, it has a built-in set of values. For example, average. I can also say give me the sum. I can also say give me the max, give me the min, etc. Right. So I've kept this code because it gives you an idea that if you write a method or a function like this, you could actually have much more complex code in here. For example, you can say get the mean RUT depth, but you can pass in a condition that says, for example, double threshold, and this is the threshold. You only want to consider RUT that is above a certain threshold. So you can say if RUT is bigger than threshold, only then increase the sum. And then I can also add a count, double count, that's also 0. And then I can say count plus plus, that means incremented by 1. I can also write it like this, equal count plus 1. And then I'm going to return here this sum divided by count like that. That's going to, so now this is a more sophisticated type of mean RUT depth, because I'm only considering RUT depth for this mean that is over a certain threshold, right? I cannot really see why you would do that, but that's just an example. So let's keep that like that. Now let's go and demonstrate how you would use this again in code. So let's first generate. You can see this code is no longer going to compile. There's a red line there because I am not passing in the required argument into the constructor, which is the RUT data. So I'm going to just create an example of that RUT data that I can use. Double RUT data, and I'm just going to say, you can see GitHub Copilot has suggested some values there. Obviously, it doesn't know much about road engineering. I'm going to add more realistic values: 2 millimeter, 17 millimeter, 5 millimeter, 18 millimeter, 2, 7, 8, 19, 32, and 12, and 7. Okay, so there we've got some RUT values. I'm calling this variable RUT data, and I'm going to pass it in there, RUT data. Now my code will compile, and now I can ask for the road segment label, and then I can also say double RUT mean is going to be segment 1 get RUT mean, and I'm going to pass in a threshold of 0. So I take into account all the RUT depth that is bigger than 0. Sorry, this is wrong. It should be get mean RUT depth, and I pass in a 0 there. And I'm just going to make this if RUT is bigger than or equal to the threshold. So if it's 0, I want the value to be included in this mean. All right, so a good way of using these type of parameters also would be to assign a default value to it like that. You can do it like that, and then you do not have to pass in a value here because it will take that default as the default parameter value. You have to be careful though with these default parameters. I prefer for you to maybe not put a default value in, remove that, and then you are forcing the implementing program to put in a value in there. So let's say give me the average for all values bigger than or equal to 0, and then I'm going to write that out to the console as well. All right, so now I've got an example of a reusable segment that I can very compactly create an instance of, and then I can use this code to return all sorts of useful engineering information about that segment. So let's run this. And you can see there I've got road 001 from 0 to 423, road name is Main Street, and there's the average value. I'll leave it to you to check if that average is correct. And you can see it returns a double precision value, so it's very long. Let's go and round that and make it a bit more pretty. So I'm going to put this with a dollar sign, and then I can start writing code that is formatted. So I'm going to say mean rut depth is equal to, and I'm going to do that. But then I'm going to use one of the built-in methods in .NET to round numbers, and to round a number, I'm going to use the .NET's math library. So I'm going to type math.round. Don't try to remember this, just ask ChatGPT if you get stuck, and I'm going to round it to 2 decimals. Let's run this again. I'll leave it to you to pause the video and just have a careful look at this code. And I am really hoping that you are not just watching, but sitting at your computer trying to type this out with me. Let's run this. And there you can see now the rut depth has been rounded to 2 decimals. Okay, so that gives you an idea of why you would want to make attributes or properties in one of your classes read-only, so that they are protected. You can have access to the variables, but you cannot modify it. And it also shows you how you can add all sorts of methods and engineering calculations into an object that represents an engineering member, like a beam or a bridge or a road layer, etc. Now, in this video, we've just illustrated the concept of explicitly declaring a class like this. But in a real-world application, this data, these numbers that you're entering here, they will have to come from somewhere. So in some of the next videos that we're going to look at, we're going to make a big jump, and we're going to keep this data that is used to generate these segments. We are going to keep that data in an Excel file, and we will show you how you can read that data from the Excel file and create these objects in a loop, and then do all sorts of useful things with them. So for one of the next videos, I want you to just do some homework and to go to ChatGPT and ask it, explain the concept and the use of NuGet packages in Visual Studio. We are going to make use of ChatGPT to help us to read data from Excel, and I'm pretty sure it's going to recommend to us to make use of a NuGet package in Visual Studio. And I want you to be already familiar with what a NuGet package is and how to install a NuGet package in Visual Studio. And that will make those follow-on videos where we're going to go a bit deeper and start building stuff with the concepts that we have up to now. It will make it a bit simpler for you. So that's it for this video. I'll see you in the next video. Thanks for watching.